Hello students and learners, welcome to the Brainbox Tutorials. I am your teacher Priyanka and today I have physics paper of I.C.S.E class 10 semester 2 examination. The paper I felt was quite good. It was from the syllabus, from the book itself. A few of the questions were a bit tricky, but otherwise the paper was good. So starting with section A, MCQ, question number 1, part 1. Free vibrations are, correct option will be option D, the vibrations with a constant frequency and constant amplitude. In number 2, diagram is given. See, the 4 diagrams of waves, sound waves are given, and the question is, the diagram below shows 4 sound waves. Which sound has the highest pitch? So the correct option here will be option number B, because it is maximum frequency. So highest pitch will be option B. Number 3 is the graph plotted for potential difference V against current I, that is VI graph for ohmic resistors is, the option will be, correct option is option C, a straight line passing through origin. Question number 4, a main switch in the main distribution board is present in. Now see, I thought this particular question was a bit tricky. The correct option is option C, a live as well as neutral wire, because remember this is main switch in the main distribution board. And if you have not read the book properly, remember the main switch generally is only in live wire, but here main distribution board is given, so it will be connected to live as well as neutral wire. Then number 5, a conductor AB is kept along north-south direction of the earth above a magnetic needle as shown below. When the key K is closed, then key K is closed, that means the current is flowing. At that time, what will happen? So option D is correct option. The needle will deflect towards west, because remember the snow rule. So it is exactly the snow rule. The conductor is in south-north position and over the needle, so needle will deflect towards west. Now number 6, a coil wound around a piece of soft iron can become an electromagnet only when, option D is correct, a current flows in the circuit. Number 7, if water absorbs 4000 joule heat to increase the temperature of 1 kg water through 1 degree centigrade, then the specific heat capacity of water is. So see here the correct option is C, 4 joule per gram per degree centigrade. And how will we calculate? So formula of specific capacity is heat upon mass into change in temperature, that is 4000 upon mass is 1 kg, but remember here answer is in gram, so let us take 1000 gram and 1 degree centigrade. So the answer is 4. That is why option C. Moving on to part 8, water is used in car radiators because, now option D is correct option, that its specific heat capacity is very high, so it can cool the engine without a greater increase in its own temperature. Number 9, the heaviest nuclear radiation is alpha radiation. Number 10, to study the age of excavated material of archaeological significance, we study the rate of decay of an isotope of, so option C is correct option, carbons. We do carbon dating. So our MCQs are completed. Now moving on to section B, question number 2. See here you will have to attempt any 3 questions. So you must have attempted any 3, but I will answer all the questions here. So question number 2, part 1, this was also a bit tricky. The question here, a diagram is given. It is written that diagram below shows a magnetic compass. Here it is, kept closer to a coil AB wound around a hollow cylindrical cardboard. So ये cylindrical cardboard है, ये wound around, that means ये solenoid बनाया है AB. This is the magnetic compass. Here is the normal direction given, south north east west, and here the switch is given. Now question number A is, after studying the circuit and the magnetic compass carefully, state whether the switch S1 is open or closed. This particular question also I felt a bit tricky because the words open, closed is written. If the words on and off was written, it was quite clear, because from this diagram it seems that the current is flowing, because the magnetic compass shows the south direction. Generally, when the magnetic compass is kept, the compass shows north direction, that is geographic north, but it is moving in south direction. That means deflection is there. That means current is flowing, and if the current is flowing, that means switch is in on position. But here it is written open or closed. Now this is a bit tricky. I feel when the switch is closed, it is in on position, and when switch is open, it is in off position. In that way, I feel the answer closed is correct, because the switch is on here, because the current is flowing and magnetic compass arrow is towards south. Okay, and I have gone through the concise book also. Everywhere, wherever switch is mentioned, on or off terms are used instead of open or closed. So it became a bit more difficult for me to exactly understand whether open is on or closed is on. Then I found one question where it was clearly written that a switch is closed and the current is flowing. That means closed is on, and in that way I can say that closed is on. So that way I think closed will be the correct answer, because it is in on position. Okay, now number B, how did you arrive at the conclusion in A? We arrived at the conclusion in A, or I arrived at the conclusion in A because of the deflection shown in the magnetic compass. It is showing the south direction. Generally, the compass needle is towards the north direction, or geographic north. It always shows geographic north. Now number C, what is the purpose of placing the magnetic compass in the above setup? So overall, the purpose of placing the magnetic compass in the above setup was to detect the presence of current, whether the current is flowing or not. I want you all to answer me in the comment box whether you have written open or close, and if you have written open or close, what did you think of, whether the current is flowing or not flowing? Please tell me. Now number 2, part A. Give an important reason for copper to be used as a material for a calorimeter. So the reasons are, see, first reason is that copper is a good conductor of heat. So the calorimeter will acquire the temperature of its content very soon. Second one is copper has a low specific heat capacity. So the heat capacity of calorimeter is low, and the amount of heat energy taken by the calorimeter from the contents to acquire its temperature will also be very small. So you can write any one of the two. Now I think that the specific heat capacity of copper is low will be an important reason among the two. Now number B, calculate the thermal capacity of 40 gram of water. Thermal capacity means heat capacity, and formula of heat capacity is mass into specific heat capacity. That means here is mass and here is specific heat capacity, but we will only have to change the gram into kg. So 40 upon 1000, this is kg. Now multiplied by 4200, and 4 2s are 8, 4 4s are 16, 168 joule per degree centigrade will be the answer. Now number 3 is, here a circuit diagram is given. In the above circuit diagram, calculate the external resistance of the circuit. So external resistance, here first we will have to calculate the parallel resistance, 1 by 12 plus 1 by 8, that is 24. 5 by 24 is 1 by resistance in parallel, that means 24 by P, that is 4.8 ohm, and 4.8 plus this 2, so 4.8 plus 2, that is 6.8 ohm is the external resistance of the circuit. Next is current I2. So here I2 is flowing, only resistance is given 8 ohm. So for current we will need potential difference, that we can calculate from I1, because I1 and resistance both are given. So I1 and resistance both are given. So V is equal to IR, that is I1 into R 1, that is 0.4 multiplied by 12, 4.8 potential difference volt. So current I2 will be V upon R2, that is 4.8 upon 8, so 48 by 80, 0.6 ampere. So the correct answer of I2 will be 0.6 ampere. And the current I is combination of I1 and I2. So just add them, 0.5 and 0.6. So answer is 1 ampere. Now question number 3, part 1. 3 wires with proper color coding are connected to the 3 terminals of a 3-pin socket. Remember, this is socket, not a plug. Match the color of the wire with the proper terminals A, B and C of the socket. This is earth wire, this is, here live wire will be connected, here neutral. So brown is live wire C, green is earth wire A, light blue is neutral wire B. So C, A, B. Now number 2, part A, why does it become colder after a hailstorm than during or before the hailstorm? Here the reason is that after the hailstorm, ice absorbs the heat energy required for its melting from its surrounding. So the temperature of the surroundings fall further down and we feel more cold. Part B is, if two bodies have the same specific heat capacities, then they will always absorb the same amount of heat if their temperature increases by the same amount. State whether the given statement is true or false. This statement is false because here the mass is not mentioned, only two bodies. So it depends also upon the mass. So this is false statement. Part 3 is, a metal piece of mass 420 gram present at 80 degrees centigrade is dropped in 80 gram of water present at 20 degrees centigrade in a calorimeter of mass 84 gram. If the final temperature of the mixture is 30 degrees centigrade, then calculate the specific heat capacity of the metal piece. Specific heat capacity of water is given 4.2 joule per gram per degree centigrade. Specific heat capacity of calorimeter is also given 200 joule per kg per degree centigrade. Okay, let us do this sum. So here are all the information given which was in the sum. See, metal, the mass of metal is 420 gram, initial temperature 80 degrees centigrade, final temperature 30 degrees centigrade. So change in temperature will be 50 and we will have to find out the specific heat capacity of metal. Then for water and calorimeter, also mass is given, initial temperatures are given, final temperatures are given. So that will be both because water is in calorimeter. So if its initial temperature is 20 degrees centigrade, then obviously calorimeter's temperature, initial temperature will also be 20. Change in temperature 30 minus 20, both will be 10 degrees centigrade. Specific capacity of water is given 4.2 joule per gram per degree centigrade, and specific heat capacity of calorimeter was given, but it was 200 joule per kg per degree centigrade. So we have changed it into 0.2 joule per gram per degree centigrade, dividing it by 1000. Now by the principle of calorimetry, we know heat lost by metal is equal to heat gained by water plus calorimeter. That means MC delta T of metal, so write metal M, is equal to heat gained by water, that is again MC delta T but of water, plus MC delta T, here we will write of calorimeter. So there is no confusion. Now writing all the values, 420 gram, specific capacity we will have to find out, change in temperature is 50, here 80 gram, 4.2, change in temperature is 10, plus 84 gram, 0.2 and change in temperature is 10. It will be specific capacity multiplied by 21,000 is equal to, let's calculate this, 3360 plus 168, that is 8 3528 divided by 21,000 divided by 8. Divided by 3. Seven. And now 21 by 125 is it is. So if we take it in decimal, 0.168 joule per gram per degree centigrade. Or if you want to convert it into per kg, so you can also write 168 joule per kg per degree centigrade. So both will be correct. Moving on to question number 4, part 1. Rohit playing a flute and Anita playing a piano emit sounds of same pitch and loudness. Number A. Name one characteristic that is different for waves from the two different instruments. So see, there are two instruments, different instrument, and the pitch and loudness are same. So the other one, that is quality, is not same. Quality or timbre, you can write anything. Now next one, number B. If now the loudness of the sound from flute becomes 4 times that of the sound from piano, then write the values of the ratio AF is to AP, that is amplitude of the sound wave from flute to amplitude of sound wave from piano. So here we will have to do a bit of calculation. So let us do this. Now see, we know that loudness is directly proportional to the square of the amplitude. Here the loudness of flute and piano are same. So loudness of flute upon loudness of piano here is 1 by 1, 1:1. But now in part B, it is said that loudness of flute becomes 4 times that of the sound from piano. That means now loudness of flute upon loudness of piano is 4 upon 1, that is 4:1. So it was earlier, but now this is the case. And we know that loudness is directly proportional to the square of the amplitude. That means we can write like this, that loudness of flute upon loudness of piano is equal to amplitude of flute upon amplitude of piano's square. Or if we have to find out this ratio, amplitude ratio, square will go to that side and it will become root. So root of the loudness of flute upon root of the loudness of piano. That means root over 4 by 1. That is amplitude of flute upon amplitude of piano. That means 2 by 1. So the answer, amplitude of flute is 2, amplitude of piano is equal to 2:1. This is answer. Now part C is define pitch of a sound. So definition of pitch is that characteristic of sound by which an acute note can be distinguished from a grave note of same loudness. Now question number 2, part A. Name 2 factors on which the force experienced by a conductor carrying current placed in a magnetic field depends. Also state how these factors affect the force. That means whether it is directly proportional or inversely proportional. So there are 3 factors. One is that force is directly proportional to the current flowing in the wire. Second is force is directly proportional to the strength of magnetic field. And third is force is directly proportional to the length of the wire within the magnetic field. You can write any 2 of the factors from these 3. Now part B is, with the help of which rule you can determine the direction of force acting on a current carrying conductor placed in a magnetic field. So the rule is Fleming's left hand rule. Fleming's left hand rule. Question number 3, part A is what is nuclear energy? And the answer to this will be the energy obtained due to a loss in mass during a nuclear change is called nuclear energy. Now number B is after emission of a nuclear radiation, the atomic number of the daughter nucleus increases by 1. Identify the nuclear radiation. Because the atomic number has increased by 1, that means the nuclear radiation is beta radiation. Number C is write a nuclear reaction indicating the nuclear change mentioned in B. So here is that reaction. So if X was the parent nucleus, its mass number was A and its atomic number was Z. It turned into its daughter nucleus, let's say Y, is mass number remaining the same and atomic number increases by 1, and there is emission of E or beta radiation, whatever way you can write, that is here -1, here 0. Now number D, what is the special name given to the parent and daughter nucleus when this radiation is emitted? So because the mass number is same, so we will call them isobars. Now moving on to question number 5, part 1. An appliance rated 440 watt 220 volt is connected across 220 volt supply. Number A, calculate the maximum current that the appliance can draw, and number B, calculate the resistance of the appliance. So let us calculate the current and the resistance of the appliance. So we know the formula P is equal to VI. Here power is given 440 watts. Voltage is also given 220 volts, so we can easily calculate I, that is 440 upon 220, that will be current, that is 2 ampere. So this is answer to number A. And number B, resistance, so that is V is equal to V square by R, or we can write R is equal to V square by P. So that will be V square, that is 220 into 220 upon power 440. 22 2s are 110. So 110 ohm is the answer. Now 5 part 2 is the diagram below shows a vibrating tuning fork E mounted on a soundbox X. When the vibrating tuning forks A, B, C, D are placed on the soundbox Y one by one, it is observed that a louder sound is produced when the tuning fork B, this one, is placed on Y. Okay, so now the question is, what is the frequency of tuning fork E? So the frequency of tuning fork E will also be same as the natural frequency of B, that is 320 Hertz. That is why a loud sound is produced. So the correct option is 320 Hertz. Now number B is, why does B produce a louder sound? So the answer to this will be B produces a louder sound due to resonance, as the natural frequency of E and B are same. So B experiences resonance, and in resonance it has a greater amplitude. Due to that it creates a louder sound. Now part 3, number A. From the graph of heating curve given below, state the melting point and boiling point of the substance. So you see here in this graph there are 2 points where the line is horizontal, here and here, and this is the heating curve. That means this is melting point and this is boiling point. So melting point is 40 degrees centigrade, 40, and boiling point is 160 degrees centigrade, 160. Now number B, complete and rewrite the following nuclear reaction by filling the blanks. So let us do this. Now this is the equation. We can clearly see that helium particle, that means alpha particle, alpha radiation has been emitted. So whenever alpha radiation is emitted, then the daughter nucleus will have 4 less of the mass number and 2 less atomic number. So if this is 90, the daughter nucleus has atomic number 90, that means atomic number of parent was 2 more, that is 90 plus 2, 92. And if uranium, that is the parent nucleus, has mass number 235, so 4 is reduced, so subtract 4 from it, 235 minus 4 is 231. So here are the filled blanks. Now moving on to question number 6. This is the figure and the question is number 1. Study the above figure and answer the following. Part A is, what type of vibration does the above figure represent? The above figure represents damped vibration because the amplitude is decreasing gradually. That means it is damped vibration. Number B, state one reason for which the amplitude of the vibration decreases with time. So the answer you can write here is the presence of resistive force or frictional forces due to the surrounding medium, that is air. Now number C is, write an example of natural vibration. So you can write, when a tuning fork is stuck against a hard rubber pad, it vibrates with its natural frequency. So that is an example of natural vibration. Or anything vibrating in vacuum, that is also natural vibration. Or you can give the example of spring, a load suspended from a spring, when stretched or compressed and then released, that starts vibrating with its natural frequency. There are many examples of natural vibrations given in your book. You can use any one. I have told you 3. You could have written any, I think 6 or 7 examples are given in your book. Now number 2, a certain beam of alpha particles, beta particles and gamma radiations travel through a region of electric field produced between 2 oppositely charged parallel plates plus and minus, that is A and B. Which of the above 3 has the maximum speed? So maximum speed, gamma rays has maximum speed. Now next is, which one deviates the most from its original path? That is beta. And which one does not deviate at all when passing through a region of electric or magnetic field? That is also gamma, because it is neutral. Number 3 and the last question is, if a wire of resistance 2 ohm gets stretched to thrice its original length. Number A, calculate the new resistance of the wire. Let us calculate this. Now we know the formula of resistance, that is resistance is equal to resistivity into length upon area. So if the resistance is 2 ohm, that means, and let us keep this as it is, so the resistivity will be 2A upon L. Okay. Now again using this formula, that is resistance is equal to resistivity into length upon area. Now this time we will have to calculate the new resistance when resistivity always remain the same. So it is 2A upon L. The length has become thrice now because 3 times its length it has been stretched. So obviously the area has decreased 3 times. So now area has become A by 3. It can be written like this also. 3 into 3 into L upon A. A cuts off, L cuts off. So 3 3s are 9, 9 2s are 18. So 18 ohm will be the answer. New resistance is 18 ohm. 3 part B is, what happens to the specific resistance of the wire? The specific resistance of the wire remains the same because the material of the wire is same. So here we have completed the solutions of physics paper semester 2 examination of I.C.S.E. class 10, and as I have told you, there were few tricky questions, especially the question with the switch that still has a lot of confusion, that whether the switch was open or closed, because open or closed both can have different meaning because it was not clearly written on or off. But this is for sure that the current was flowing because the needle was deflected. Write to me in the comment box how was your paper and what have you written for that particular question. And I will bring answer key to the other science papers as well, that is chemistry and biology. So keep watching my channel, and if you haven't subscribed to my channel, subscribe it and share with your friends. Bye bye. Jai Hind.